Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial, I'll be trying to do another ML interpretation with Eli5, Shap, and then Lime, right? So we'll be trying to interpret PMS diabetes prediction with Eli5, Shap, and then Lime. So now let's see how to work with it. So first of all, we're just going to load our EDA packages, that is NumPy, and then Pandas, and then also load our ML packages, which will be using logistic regression, KNN, and then you load our train test split as well as our accuracy score. Then let's load our visualization packages, right? So we'll be using Matplotlib as well as Seaborn to help us with our visualization. Perfect. So now let's move on to what we're doing. So we'll be using our dataset from PIMA dataset. So the dataset already do not have labels, right? So these are the labels we're using: the number of pregnancy, glucose concentration, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, age, and then the outcome. So the outcome is going to give us two different outcomes. We have 1 for diabetes and then 0 for non-diabetes, right? So this is going to be our names that we'll be using. Now let's load our dataset. It's going to be df to pd.read underscore csv, then PIMA dataset, right? So that is the particulars that we have. So since this one doesn't have a header, I'm just going to supply the names is equal to names, right? So this is going to supply that names as a column name. So if I check back again, df.head, now we have it as perfect, right? So we have the column headers there. Nice. So now let's check for the size of this our data set. So it's going to be df.shape. And then when you check for this, we have about 768 different data points and then 9 columns. So let's check for missing values. So it's going to be no, we can use isNone sum. I can spell the sum. Perfect. To check for presence of missing values, right? So there are no missing values there, right? So there's another particular package that can also help us to visualize this. You can just go with this. So import missing no, right? Missing no as no, right? There's a simple package, and then we can use this particular package to visualize that star that we have. So it's going to be no.bar n.bar. Then I can pass in my data frame, right? So if I go with this, it's going to visualize it in a very simple way for me. That is another package you can also do. So it's checking it to see if there are missing values. There are several formats you can do, so there will be a whole tutorial on how to work with it. You can do a lot of things with this, and even go on with this particular option of matrix or heat map, and then it's going to also plot it in a simple way for us, right? So this is how it's going to be. So it's not that bad. So let's move on. Now let's see the data types for this. So we have for our data types, it's going to be df.dt. Then we want to check for the data types. So we are working with numbers, right? So we don't need to do any vectorization. So integers and then float. Now let's check for the occurrence of each and every of the class. So to check for the occurrence of the class, it's going to be df.group by, there are several ways you can do that, by the class that we have. Then we're going to check for the size. So by this particular option, you'll be able to check for the size, right? So we have 0 for the non-diabetes is 500, and then for the diabetes is 268. So this is not an imbalanced data set, right? So it's okay, because in real life you're not supposed to have a lot of people having diabetes. Okay, now let's see how to plot this particular stuff. So to plot it is going to be very simple. You can just use the same thing to plot. .plot. Then the kind is going to be bar, right? It's going to plot it in a very simple way for us. So perfect. So we're having the class of 0 of non-diabetes at this point, and then the one for diabetes at 1. So it's not that bad. Okay, now let's see some correlation between them to see the correlation between each and every of the characteristics, right? Because this is diabetes and it's a disease, so you have to know the different features, the different characteristics that contribute to produce diabetes. So let's do that. So it is going to be df. Let's go to correlation. Core is going to be df.core. So it's going to be this, right? Perfect. Now we can rather print it out. So let's go with this, and then going to print the correlation between all of them in a simple way for us. So perfect. So there's a correlation. So you can see from here that the correlation is the one is at the same together. So now number of pregnancy is given us 1. So we're going to correlate it for us perfectly to know the kind of relationship they have with each other, right? Now let's see some other interesting stuff we can also do. So we can also do some data visualization of the entire stuff. So let's try that one. So it's going to be the normal pandas stuff. So use the histogram to plot the entire stuff. So it takes some time to plot the entire features, right? All the data that we have in a simple summary. Perfect. So you can see from here that our BMI is having 0 here. So BMI must not be 0. You have some 0 points here, and then it is not that bad. And BP has some 0. So BP is not supposed to be 0. You can have BP 0, right? Except if maybe systolic pressure of 0, but it's very rare. Then you also have here for the classes. Okay, 0 is normal because you have 0 and 1. They are the normal classes. The pedigree 2 is also normal. Glucose 0, glucose. Okay, so you have to tell me that you have to check and then scale BMI, BP, glucose, and then maybe insulin, right? And then skin thickness. So some of these things you have to correlate. So 0 is possible because not that people may have not given birth, right? So this is possible. So that is something we can do. So now let's try and do a descriptive analysis of all that we have so far. Since this is numbers, it's very easy to do. So df.describe, right? Then with the describe like this, we can be able to go through it. But if you go with this format, it's giving us in this format, right? You can actually transpose it. So let's try that one, the transposition. Right, instead of it going like this way, we can also change it to transpose it .t, right? And then .t is going to transpose the entire stuff. So perfect. So now it's a nice format for us. We have number of pregnancy, the count, the mean, the glucose, and all of these things, right? So looking at this data set, we realize that the mean of glucose is higher, right, than all of them. So that means that glucose will have a very powerful influence on our data set. So let's see some data cleaning to clean all these anomalies or not anomalies. Yes, outliers we had 0, 0. Yeah, so let's try and see. So I'm going to check for going to remove all the zeros since BP and then BMI and all of these things can't have 0, right? You can't have a BP of 0. That means the patient is dead. So let's go with the normal one. So df.bp, right? To check for the minimum value, you can just go with .min. So if you go with .min, it's going to give us 0. So if you give us 0, that means that the minimum value is 0, which we can't have, right? So we can also check for that for the other ones. So we can do the same thing for BMI, and then which is going to be for BMI can also do the same thing for glucose, right? And then we can also do another one for, let's say, skin thickness. And then this is going to be for our insulin, right? So if I print it out, see that now BMI is 0, 0, 0. So that means that I see how I express glucose. If you check it, you see that 0, 0, 0. That means that some of the values are 0. So you have to replace all of them with a median or a mean, right? So let's see how to do that. So since is BMI, we can actually replace the BMI with the median, right? Not the mean, because if you put the mean, it's going to be very high. So let's do that one for the BMI and then for the BP, right? We can do that for the median. So how do we do that? So there are several methods. Just go with DF. Then let's bring it as BMI or BP first. BP. So df.bp. Then here I can just go with the normal format of dot replace. You can use a fill now, but let's go with the dot replace. Then we have this particular option of replace. The value that I want to replace, I want to place 0, every 0 there with value. And the value I want to replace it with df, the mean, right? So bp dot median. So that's the value I'm actually replacing there. So I'm just replacing every 0 with this particular value. So let's check. See, now if you go back and then we check for the BP gain that we had here. So let me copy this one. Let's just paste it here, right? So I'll paste it here. Then let's check again. So now see that now it is 24. It's no more 0. unlike the previous one that we had, which was 0, right? So that's what we'll be doing for all of them. So let's try that one. So I've already done it so that it becomes faster. So we will place the BP, the BMI, the insulin level, and then there's another format of also doing it. You can also use the fill now, right? So fill now is going to fill all of them with the NAs with this particular value, right? That's another option apart from using the replace too. You can also use the fill now, and then you can also do that one for this, which is also going to work for us. And then for the skin thickness, so now we have filled all of them. So now let's try and plot it and see our plot so far, right? If I plot it, unlike the previous one that we plotted, that we could see some outliers like zeros and time. Now that doesn't make sense. With this particular plot, you'll be able to see the difference. Perfect. So you see that now BP has no 0, right? BMI has no 0, BP has no 0. That makes sense, right? And then we have, this is normal, pedigree, normal, glucose, we have no 0. So now it is making sense, right? Perfect. But this thing did not change. But anyway, let's still move on, because it's possible that insulin will still be 0. Anyway, then the skin thickness too did not change, because I use a fill now. Anyway, now let's move on. It's not going to affect anything. So now let's see some of that. So you can also use this particular option that we did again to check for it, right? With the missing NO. So NO.bar. We can also have heat map. It's very interesting. Heat map. Then let's go with our DF. You can do a lot of things with this particular stuff. Oh, it's not heat map. So there are interesting things that you can. So there are interesting things that you can also do. So just go with NA dot, let's say matrix or bar, then DF. Perfect. Okay, so not that bad. So now let's see some feature preparation. So how do we prepare our features? So let's go with df dot columns. We want to prepare our features. So we have these columns. So we want to use all of these things from numbers to class to age to be our features, and then our class is going to be our labels, right? So it's going to be, so that's what we're trying to do. So to select is going to be our S features. So S features df.ilog. They are selecting from, because from here we realize that there are 9. So let's check and see. So df.shape. So we have 9, right? So we have 8 of them is going to be our features. So it's going to be ilog is going to be this. Then 0, 2, 8, right? So that is going to be our features, right? 0 to 8 is going to be our features, and then we'll be using the rest for our labels, right? Perfect. So let's try, and then our labels is going to be df class. So that is it. Perfect. So now let's scale our data set, right? You have to scale them because some of them you have to scale them to make it better, right? So using from Sklearn, you can use min max scaler, you can use standard scaler, any of the scalars you can use. Now let's try and scale this. So it's going to be scalar, it's going to be scalar. Then I'm just going to set at S the scaled value, right? Scalar dot fit transform. Fit transform. 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 Fit transform. Then I'm going to supply the particular feature that I have. So we are going to scale them, right? Perfect. So to make it interesting. Okay, now perfect. Now after scaling them, you can be able to check for the shape. So if you check for the scaled stuff, you can also check for the shape. So again, because we have still going to be the same thing, right? 8. So that's going to be the shape, right? Very interesting. But this particular stuff that we had here, if I go back to this S, right? So that it's going to give us these values. But this is not the best way. You need to be able to give it some labels, right? To give it some names to know which one is which. So to do that, you are going to create another data frame, which is going to be called S again. Then I'm going to supply the particular value that I have. So pd dot data frame. So data frame. Right, and I'm going to supply the S that value that we have, the one we had here from this place. This S value, I've done it again so that we don't make mistakes. So I'm going to supply that same S value that we have here. And then the columns. So the columns is going to be names. So how do we do that? So let's set our names. The names is going to be from the first one we had we had names here previously, right? All of these things. So we just need 8 of them. So 1, 2, 3, 4, 5. So it's going to be 0 to 8. Perfect. So that is going to be all of them. So we're going to supply these names here. Names is going to be 0 to 8, right? Perfect. So now we have built a very simple data frame. So if I go with s.head, now perfect, is working well. So this has been scaled nicely. Unlike the previous one here, that was different, right? All of these things were different. So these values were totally different. Now this has been scaled well. It has been scaled well that we can use. So I'll split on it. I'll split it into training data set and then testing data set. And then now let's build our model. So to build our model is going to be very simple. You can use KNN or logistic regression, which is a classifier. So let's try and use that one. So it's going to be logistic regression. Then we're going to initialize it. So after initializing, we need to fit it, right? We need to initialize it first. Then let's fit the data together. So logit our model dot fit. Then we are fitting our S train and our Y train. So S train and then our Y train. Perfect. So to build itself, perfect. So I need to build a very nice one for us. Now we can be able to check and use it very well. So let's use it for our accuracy. So it's going to be print accuracy score or prediction score, any of them. Then it's going to be our logis. Bring it up a little. So logit dot score. Then our S test. And then our Y test. Perfect. So if you check it, not about 77%. So it's not that bad. So that is how our model accuracy is right now. Let's do some simple prediction. So I'll be predicting. So wait, let's check with test data. Test dot values going to be 0. So 0, right? This is a particular value that you want to predict on. So how do you predict it? This is a whole sample, so you need to be able to make it into a single sample so that you can be able to predict on it. So to do that, it's going to be logit dot predict, right? Our model that you are using to predict. Then I'm just going to shape it. So array, that's why we imported the numpy. Then s test dot value. You can use ilog if you want. Values. So you're taking that particular value, right? Dot reshape. And then I'm just going to shape it as a single sample. Perfect. So this gave us 0. 0 means that it is no diabetes, right? No diabetes. So now that is the prediction that we have now so far. Now let's see how to explain this particular prediction. Why it gave us as no 0. Let's use another prediction so that we have 2, so we can try with it. It's going to be prediction 2. Let's give it as number 5, and then let's see. This is also no diabetes. Let's use something different. Let's make it like 30. 1. Okay, perfect. So we have one that is diabetes. So this is going to be value 30. DM, right? Value 30. And then this is going to be for no DM. No non-DM. DM means diabetes, right? Value 0. So we have one that is predicting as diabetes and one that is predicting as not diabetes. Now let's try and interpret this particular model using all of these 3 interesting packages. So we have Shap, we have Lime, and we have Eli5. So Shap is a very powerful explainer, interpreting model explainer, and then it is based on Shapley values, right? So it's based on game theory. So what do I mean by game theory? Like for example, like if you are playing a game, we have players and we have the end game of winning the game, right? So every feature is like a player, right? So at the end of the game, they have to win, they have to score, they have to get a reward, they have to get a payout. So how is each and every of the players going to contribute to make sure that we win? That is how Shapley is working. It's working on game theory. So we have several explainers. We have tree explainer, which is used for these tree-based models, right? SGBoost, CAT, Sklearn models. And we also have deep explainer, which is for machine learning, deep neural networks like TensorFlow, Keras, all these deep learning models. We also have gradient explainer, which is also for PyTorch, Keras, and then TensorFlow, and then this is how to do that, right? And then also have the kernel explainer. So the kernel explainer is what we'll be using in this particular tutorial. It is used to explain any function, right? And it's very slow because it gives an approximation, so it is good, right? So you can use it for SVM, KNN, all of these functions. So now let's load our package. So import Shap. So it takes some time. And then one thing about Shap that you need to initialize JavaScript, right, to be able to allow us to do the plotting. So I'll just initialize JavaScript, so let us initialize our JavaScript here. Now let's see how to do our plotting. So to plot it, it's going to be very simple. We need to create an explainer, which is going to be used to explain. So let's go to that explainer. Explainer, right? Then Shap. So as we already learned that this is just a normal function, right? So to explain any function, any model, which is not a deep learning model, which is not a tree-based model, we will be using the kernel explainer, right, to explain it. Although it is slow, but you use that one. So dot kernel explainer, right? That's what we're using. Then we're going to supply our model. So it takes the argument just as here. It takes the prediction function, right? That is a model. Then the data. Then the link. The link is going to use a logic, which is a log connection. So there's a documentation on it. Okay, so now let's move on to what to supply. So to supply, we need to supply our prediction function, right? So log it's our model, log predict proba, right? That is going to be our prediction function. Then we need to supply our data, so it's going to be a string. Perfect. So this is what we are going to be using, right? So we don't need to set the logic. You can set it, it's optional. Okay, so now it's going to take some time. Perfect. So that's about it. So most of it, when you are doing it, it's going to tell us that to summarize it with k-means. So you can also do that with the k-means to summarize it, right? Now let's work on our Shapley values. So our Shapley values is going to explain it. It's going to be used to do our explanation. One nice thing about Shap is that's an advantage. It's able to explain all the different features together, right? Unlike Lime that picks one particular feature and then explains it. This Shapley picks all the different features, which is very good, but makes it slow. So let's see how to do it. It's going to be Shap value. It's going to be our explainer that we created above. Dot Shap values, right? Then we're going to supply our s-test. This is going to take time. So this will take a lot of time. So let's see how to do that. Take about maybe like 20 minutes. So we'll pause it and then we'll come back to it when it is done. Okay, now our plot okay, now it has finished doing whatever it was doing. The reason why it took long was that we were trying to build the Shap values for all the entire data set, right? So it took a very long time. So let's see how to do a force plot for the entire stuff. Then we do one for a single stuff. So let's see how to do that. It's going to be force plot for all predictions of the entire stuff, right? Of entire stuff, entire data, right? So today is going to be our explainer, or it's going to be our Shap.force plot, right? Then with the force plot, we can going to supply in some value. So we're going to give our explainer that we created above, explainer.expected value. Then this expected value takes 0, right? Then we're going to move on to our Shap values. So this Shap values is the one that we had from above. Then we're going to supply our entire data set test. So with this, we're going to plot it in a very simple and a nice format for us. Voila. So you see that that's plotted in a very simple way with all the features and then everything together, right? So it is very nice, very interesting plot. And then one of the advantages of Shap is that like it is easy, it is good, it includes all the features, but it can be sometimes can misinterpret it, right? If you don't know how to interpret it. So let me change it from here to white so that you see it very well. Okay, back to white. Took a long time. So this is it, right? So this is how it is explaining it. So we have the sample order by similarity, here. So as you change it, you can actually change the particular stuff that you want to do based on the output, and then it changes, right? So you can see that we have two different colors. We have red and then a blue. So the red is usually trying to tell you the features that are contributing, that are pushing to make the prediction so, right? So we have a base value, which is the expected value that's supposed to be. So the red is going to show all the features that are pushing to make sure that you reach that particular prediction, right? From the base value. And then the blue, all this blue is also all the features that are pushing it away from the expected value, from the base value. So this is interesting. So the several things you can just supply it to maybe one particular as the glucose. Then so you see that from here we have glucose concentration that is pushing then all of these things, right? So the explanation is interesting. I'll link a video below to explain more. Now let's see how to do a single prediction for something single, right? So it's going to be example, a single prediction. So let's go to shap values 2, right? Then I'm going to create a simple explainer. So explainer dot, yeah, building something simple to do that. So shap values. Then I'm supplying something simple. So you realize that from here, from the one we had here, let's go here. From here, we realize that we had for the entire stuff, right? We created the shap values of the entire stuff, but we don't want to quit for the entire stuff. We want to quit for only one particular prediction, right? So it's going to be the same thing that we had here. I'll copy this and then I'll paste it here, which we already have pasted. Then I'm going to make sure that it's only one, not the entire stuff. So it's going to be .ilog of one particular value, so 0, which is going to be this. So let's try and see what this particular stuff is before we go and do our prediction. Okay, so let's try it and see. So if I check this, perfect, right? So this is a single sample, right? We want to predict this particular sample. Realize this prediction was the one we had previously that it gave us as 0 here, right? Which is no DM, and then we had another one for 30, which was 1, right? Which was DM. So we want to explain that particular prediction. So this was for the entire stuff, but we want to do for the individual stuff, right? For individual. So just going to build this stuff. I hope it doesn't take a lot of time. Perfect, is building. Perfect, so that's finished building. So it will not take time because it's a single value. So from that point, now let's see how to do that. Let me put this on here. And let's see how to build our stuff. So to build it, you're just going to use the same format we had. So it's going to be shap. Let me copy that one because it's the same. With the same thing for the plotting. It's going to be this stuff we had. So this is a single plot, right? So a single plot. So it's going to be this. So first plot explainer, expected value. Then I'm going to supply value. Then I'm going to supply the particular individual value that we have. So .ilog. And then 0, the value that we predicted, right? Perfect. So this is it. So we realize that here we use sharply values 2. So that means that this one should be 2. And I'm going to use it to explain it, right? So sharply value 2. Perfect. So now it's explaining it in a simple way. So this is for a single plot or a single prediction. Single plot or prediction, right? It's not even a single plot, it's a single prediction. Okay, so single prediction. So from here you can understand why this one gives us as 0, as no DM, right? So the reason that this is the base value. The base value is 0.64. That is the base value that is expected to be, right? And then this is the output it's given to us, right? At 0.7, right? So this is the output is given to us. So what are the features that contributed to make this particular prediction as diabetes, right? Or as non-diabetes, because this value was non-diabetes. So it's telling us that the concentration, it is very interesting that it gives us based on the order. So the insulin level was low, right, from this particular point, insulin, and then we had insulin of 0.22, and then the glucose concentration of 0.34. So this glucose concentration is what is pushing the base value from here to this particular output value, the expected value that made us have that particular prediction. I hope you get it. Let me explain it again. So this is a single prediction, right? And then from our prediction earlier, we realized that this value was non-diabetes, no DM, right? So why is it giving us no DM? Based on Shapley values or the explanation, it's saying that this is the base value, right? 0.6. And then you have an output value which is 0.7. So why did we reach there? Why is it giving us this particular prediction? So it's going to give us orderly the kind of features that contributed to push us to this particular point. So the red means that there are features that are pushing the prediction from the baseline to that expected value, right? And then the blue means that there are features that are pushing it away from the base value. So we have insulin, 2 hours insulin of 0.2, and then we also have glucose concentration of 0.3. So these ones are the ones that are pushing it to this particular output value, right? And then these ones are the ones that are pulling it away from the expected value. So it's very interesting and very simple to do. So that is for a single prediction. So one thing about Sharp is that it's fast based on if you're working on one circular stuff, and it takes a lot of time if you're working for the entire data set. So let's see how to do a summary plot, right? So sometimes you can also do a summary plot to help you know more about it. So to do a summary plot is going to be quite simple. Just go with the normal stuff of Sharp, right? Dot summary plot. Let's switch back to our that thing. Okay, not that bad, right? So here is interesting. It looks nice anyway. Okay, sharp dot summary plot. We have summary plot. So the summary plot you can just use it for the entire stuff or for the individual stuff we have. So we have Shapley values that we have, then our S test. So if I run it, it's going to give me a very simple, nice plot. So what is all the features, right? Which of them are contributing more to give us a particular prediction? So this is how all of them are contributing. And then this is based on the order, not on how you put the data set, but the order of importance, the order of features that are contributing or giving an average impact, right? So we have glucose at the highest, then you have BMI, we have age, we have number of pregnancy, pedigree, BP, and then insulin and skin thickness. Skin thickness is the least, right? Glucose concentration is the highest because it's diabetes. So this is what is actually pushing us to give us this particular prediction of either class 1 for diabetes or class 0 for no diabetes. So that is what is contributing to give us this particular value, right? So we're able to understand which of these features are actually giving us this particular prediction. Okay, now let's see again another plot you can also do. You can also do a dependency plot that shows the effect of a single feature, right? How each single feature has on the prediction, right? The kind of effect that a single feature has on the prediction. So how do we do that? It's going to be individual. You can plot with sharp dot dependency plot. Then you supply the particular stuff you want to do. So it goes with this particular option, the particular index of the feature you want to predict. So maybe you want to predict maybe glucose, you want to predict BMI, you want to predict age. You want to see the effect of that particular feature on the entire prediction, right? Then also go with our matrix sharp values, then our data set, right? So it's going to be our 0, which is our first index of. Then we move on to the next one. The 0 here is based on what we have here. Let's see the index so that it becomes easier. So we had our data set of df.head. So from here we had this is 0, right? 0, 1, 2, 3, 4, 5. So we want to check for the particular effect of number of pregnancy on the entire prediction. So it's going to be 0, right? That is the first one. And we're going to supply our sharp values. So 0, right? And then the next one is going to be our entire data set, right? So test. So if I go with this, I'm going to plot it in a very simple way. Perfect. So this is a particular plot it's given to us. So sharp values of the number of pregnancy. It's automatically stated as its number of pregnancy. Then it's given us an explanation of the dependencies of these particular values. And then another plot, maybe age, on giving us a particular prediction. Right? Remember that blue means that it is moving away from the prediction. Red means that it's moving towards the baseline, from the baseline to the expected value or to the prediction value. Okay, now you can also do the same thing for glucose. Whether glucose was glucose was 2, right? So you can, or 1 or 2. So I can set this one to 1. Then if I plot it, it's going to give us a totally different plot, right? So this is also a different plot. Perfect. So that is how to check for the dependency of a particular feature on So that's how to check for how each feature is dependent on the prediction or influence the prediction. Okay, that is something interesting. The explanation may not be clear, but I'll link a video that gives a brilliant explanation of all of these things below. Now let's see our prediction for the one that we had. We remember that we had for this was for diabetes, non-diabetes, right? We had this one for non-diabetes. We want to do that one for the one we had for the diabetes, which was the 30. So let's go to here and then do that one, then we move on to the next particular stuff. So this was for the non-diabetes, which was 30. Right, but before we do that, you have to actually create a Shapley value for that. So let me copy that one. So this for 3. This one was for 3, right? This was for the 3, and then this is going to be 30. Perfect. I'm going to bold it for us. Take some time. Perfect. That's finished building. Now I can use this one for it. So this was 3 to explain it. This one is totally different. See, from this particular diagram and the one we had is totally different. Now it's telling us that it is diabetes, right? So what are the things that are pushing it from the baseline, right? So here we had a baseline of 0.64. That is the expected one. Then it is moving it opposite to the negative option, right? So this is totally of pushing it to give us that particular prediction of diabetes, right? The number of age, the number of pregnancy is 0. So that means that the pregnancy is not affected. The age is also 0. That means that it's not even affecting it. But these ones, the BMI is high. The glucose concentration is also high. And the pedigree is also high. So these particular features are pushing it to give us our output value, which is our prediction of diabetes. Okay, now let's move on to using Lime, right? So Lime is also a very powerful package that allows us to explain it. So what's the meaning of Shap? We have done all of these things, forgot the meaning of Shap. So Shap is an additive feature attribution method, right? So it's an additive feature attribution method. It stands for Shap. Shapley. It's the name of the law. It's Shapley additive, right? We are adding them. That's the full meaning. Additive explanation. So that is how it works. So how does it work? It's going to find the sum, right, of all the features. Something simple. Then how is it doing that? It's find the average. It's averaging the entire stuff. So it's going to just be the sum of all the prediction, and then we have the prediction, the expected prediction, right? Expected, and then the base prediction, right? So prediction. So that is how to do that. So that is some mathematics about it. It's not important, but something to let you know. Okay, now let's move on to Lime. So Lime is a very powerful package that allows you to do it faster, right? It's fast, and then it allows you to be able to interpret your model agnostically. So let's see an example. I'm just going to import Lime and then Lime tabular data. Remember that we are working with tabular data, right? So that's why we are using Lime tabular. Then we're going to create our feature, our class names. It's going to be these ones, and then we need to create our class name. So class names, let me bring up a little. This is for Lime. The class name is, we have 0 as diabetes and then 1 as non-diabetes, right? So 1 as diabetes, 0 as non-diabetes. So it's going to be non-DM diabetes for 1 and then diabetes, right? So this is the class name that we'll be using. Perfect. So let's see, and we also have our feature names. So it's going to be our feature names. We have all these lists of our feature names. This is the S value, the features that we'll be using. So to create our, first of all, we need to be able to create our explainer. We need our data model, our class name, which have created our feature name, then prediction function, then we create our explainer. So let's create our explainer. So the explainer is going to be very simple. It's going to be our explainer. Let's put explainer 1. Don't want to confuse it with the other one, right? So explainer 1. So lime tabular. Then I'm going to supply the other one. So lime tabular, then we are using lime tabular explainer. Then I'm going to apply the value. So the value I'm supplying is our data, our train data dot values. Up it goes, dot values. Then the next one is going to be our feature names is going to feature names. Yep. And then our class name or our target name is going to be our class names. Perfect. So we have it perfectly. Then we can also set discretize as continuous, right? Discretize continuous to true. Perfect. So it's going to play now. Great. And then I'm going to do a simple prediction. So this is what we did previously. So we had test.ilog or .value, any of them, of 0 that give us these values, right? And then that is what we predicted as not having diabetes. So we want to explain it. So how do we explain it? So let's create a simple explainer. So ESP1 is going to give us the particular explanation. So it's going to be our explainer. This is our explainer instance, right? Our explainer 1 for our line, then explain instance. Then we're going to supply our stest.ilog. We are doing for one singular value. Then our prediction function, right, which is logit.predict right, predict probability. Then the number of features we want to predict on. So number of features is equal to, we have 8 features, right? We want to show all of them. These are 8 features here. We want to show all of them. Then top label, right? Go to 1, right? Perfect. So let's see. Now we have created our explainer. I need to be able to plot this particular explainer that is created. So it's going to be this. So esp1.show a notebook, then show a notebook, right? We have show a notebook, we have show tab, let's go to true, then show all, let's go to false. Perfect, right? So let's see our plot. Perfect. So it has been able to plot in a very simple, nice way for us. So we have our prediction as being non-diabetes, right? From our prediction, we realized this was 0, right? And even from these ones we did here, we realized that this was for 30. This one is diabetes, right? That is why it is going to this side. These are the features that are contributing to give us that. Then this one was non-diabetes, right? This was non-diabetes. So these are the features that were pushing it away from making it from being diabetes, right? So this is non-diabetes from previously. So from here we are realizing that we are trying to use Lime to explain this particular prediction. So what are some of the things that give us this particular prediction? We have diabetes and then non-diabetes. So what are the things that influence this particular prediction to give us non-diabetes? So we realize that glucose, yellow, right? Yeah, orange, orange or yellow, any of them. So orange means that it is diabetes, and then blue. So the features that are contributing to give us non-diabetes are the A, which is higher than 0.32, and it's contributing this particular weight to give us this non-diabetes. BP was 0.2, and then we also have these particular values, right? So these are the features that are contributing to make sure that this is not a diabetes, this is a non-diabetes. So we have age, the BP, then we also have BMI, we have number of pregnancy, and then pedigree. So these particular ones in blue are the ones telling us the features, they are contributing their weight to make sure that we have a prediction of 0.7. Right, 0.7. And then here is like the diabetes. These are the features that will push it to diabetes, which is less, right? So the expected one is supposed to be 0.36, but the one that we have is 0.22. That means that it's less, so it is not a diabetes. Very simple, right? So that's how to use that to do that. In the same way, you can also apply it for the one that we have for the 31, right? Which is going to be here the explainer. Also, it's the same thing. So let's go with this. Copy this one. We are trying that one for the 30, right? The one which was 32, right? And then we do the same thing here. So I'll build this one up here, explainer instance. Then we also create another one for the show table. So we're going to be explainer 2. So let's see what it's going to give to us. So this is supposed to give us diabetes, right? Perfect. So now this is giving us diabetes, which is as predicted. So these are the features that are giving us diabetes. We have 0.7 as a prediction probability. So all these ones in orange, glucose level is very high, BP is also high, and then these are the things, BP, glucose, and DM pedigree are the things that are contributing to make sure that this particular prediction is diabetes, right? That is why diabetes 0.7 is here. And even if you look at this stat that we had here, you realize that here was perfect. So that is how to work with it, right? So we have been able to do and understand using 2 methods, Shap and then Line. Now let's see how to do that with Eli5. Explain that I'm 5. So I'm just going to import this one, Eli5. Then I'm just going to show the weight of it. So it's going to be quite simple. Eli5 dot show weight of our model. Then the entire top stuff, right? We want to show for the entire model. What are the stuff that are giving us this? So if I go with this, so these are all the stuff that are giving us this particular prediction. So let's go back to white. Perfect, right? So wow, this is nice. Oh, sorry for not changing it. Anyway, okay, so let's do that one for a single one. You can also do it for a single prediction. You can also define the features by supplying the feature names so that it actually gives us all the features, right? The feature names, not just the values like we have here, but also the particular features. So in that case, it's going to be this, copy this one, and then supply the features that we have, which was the features name. So feature names, right, and then the class name or target name, right? It can be target name or any of them. So let's make it target name. Target names can spell. Okay, so let's see. Perfect. So these are all the particular features, right? So this is how it's going to give us if it's diabetes, right? So these are the particular features that is going to give us that. Now I want to do a single prediction. So for a single prediction, it's going to be the show prediction, not the entire stuff show weight. So it's going to be Eli5.show prediction of a particular value. Then we supply our model. Then we supply the particular value that we want to test. Test dot ilog. We had 0, which is non-diabetes. Then the features, feature names, going to be feature names, right? Now class names or target name, class names. Perfect. So now we are done. So let's run it and see. So this is non-diabetes. Perfect. So these are the particulars that are contributing to give us a non-diabetes prediction. So you can use the same thing for the other one that we had, which was for the diabetes, right? So all these things are contributing to make sure that this is non-diabetes, right? So even glucose is very low, and this is what is making that BP is high, this is high. So if you go for the 31, which is diabetes, it's going to give us that diabetes, right? So glucose is higher, right? Very interesting, very high. So glucose and BMI are the higher feature that are contributing to give us diabetes. So thank you for watching this long tutorial, right? So you have been able to see how to explain why the PIMA diabetes dataset predict one is a diabetes and one is not a diabetes using several methods, using Shap, using Lime, and then using Eli5. This has been a very, very long tutorial. Thank you for staying with me. I know I was rushing, but Don't worry, this is just a learning tutorial. So I hope you have learned something. So in case you have any question or contribution, you can just put it in the comment section. And please don't forget to subscribe and share. Stay blessed.